Hello everyone, it's Mr. Rops here, and today we're going to talk about, we're going to use matrix algebra to take this diagonalized matrix D, this diagonal matrix. We know that's true, and we want to solve for M by matrix algebra. And so if I take this equation D, which is equal to P inverse M times P, I want to move the inverse and P over to the left-hand side. I can't divide because matrices don't divide. I have to multiply. And what I can do is if I want to multiply and get rid of P, what I can do is I can multiply this by P inverse. And the reason why I can do that is if I go P times P inverse, that's equal to the identity matrix I. So this is in essence 1. So if I multiply on the right-hand side of P inverse, then I must multiply on the right-hand side P inverse. Similarly, I want to get rid of the inverse here, so I can multiply P on the left-hand side, so I have to multiply P on the right-hand side. I know, again, that this is I times M times I, which I also know is just M. And so M is equal to P times D times the inverse of P. All right, so now that I have this result, I can use it now to generalize, or I can show I want to solve for M cubed. Well, if I want M cubed, this is B part, I know what it's going to be. It's going to be PD P inverse times PD P inverse times PD P inverse, because that's cubes, M times M times M. But again, here, if I have those two together, that equals I. These two together equals I. And so these in essence cancel out. It's like multiplying by 1. And so if I put this together, I have P, I have D times D times D is D cubed times P inverse. Okay, so now if I want to take this idea and generalize it, I can say M to the power of N. Well, the idea here is just that it's going to be P times D to the power N times the inverse of P. And so this will find us M to the power of any value N by doing this particular calculation here. And I also know that in my formula booklet, I have it written for me. And so I don't have to memorize this one. It is just given to me, but it's handy to know. And it's quite intuitive to know as well. The only thing I always have to think about is which one goes first, the regular one or the inverse. But this all kind of seems, when I was learning about this, it all kind of seems pointless. Like, why in the world can't I just throw this into my calculator? If I want to do M to the power of 75, I can just throw out my calculator to do the calculation. And what it turns out from doing a little research is that doing this, multiplying M 75 times, is actually quite a laborious computation, even for computers and calculators. It is far more efficient for computing devices to do this calculation. It's just able to do it faster. And so then it gives more memory space or computational power to do other things. And so that's one of the uses of diagonalizing matrices today.